I am very excited about the next. I mean, I've been excited about every single one of these conversations, but I'm particularly excited about this one, just because not only because we have a fellow Berliner, he is not too far from where I am right now in Prenzlauer Berg. I'm in Wedding, in case you know the geography of Berlin, but he is really an artist that deserves to be called a legend, just because many of the things we do day in, day out wouldn't be the way they are without his work and the work that he had put in, the experiments that he dared to do when nobody thought about them. And we all should be internally grateful for that. But also some of his methods are arcane and mysterious, and I'm very happy that Harm van den Dorpel will tell us all about how he does the beautiful things he does. So please, everyone, a warm applause for Harm van den Dorpel. Please enjoy, friends.
Hi, Michal. Thank you for the introduction. Can you hear me? I will be.
Yes, very well.
Excellent. I'll be doing quite a bit of screen sharing. I'm usually, when I'm invited to be in panels or give talks, I'm usually asked to talk about the art, the aesthetics, the art historical references. And this time I was asked to actually more like have a technical talk, which is exciting. I rarely get to do that. So I will actually be talking about smart contract programming, and I've been doing that for a while. I think I started playing with Solidity in 2018, 17. And why I think this is interesting to talk about in an art context is because what makes NFTs for me is the fact that they are immutable. So they are to some extent unchangeable, fixed, and that means they are resilient. They cannot be taken down by a government, but also it addresses the difficulty that I experienced earlier before blockchain with digital art, because the software art, digital art is so easy to change. It's so easy to disappear. It's so easy to lose it somehow. And the ephemeral nature of digital art, which I've always loved, is really nicely complemented by blockchain technology, where you can actually fix certain things of your digital artwork. Of course, with the benefit that it is resilient, it cannot be censored, but also it makes it really easier to commodify. So you have this enormous this market of NFTs, for which artists greatly profit. This talk is called on-chain NFTs, and some people might ask, like, aren't all NFTs on-chain? So I'm going to show a few examples of how different NFT projects are on-chain, or to what extent they are not on-chain. And most of the times, the parts that are not on-chain make the artwork more flexible, but also less resilient, and more prone to changing. I'm going to share my screen, and I'm going to show some examples. So can you see my screen now? So this is actually the project I'm going to touch the latest. That is my own project. For you, I think many of you will be familiar with the Ethereum NFT standard, ERC 721, where basically the only thing that is stored on-chain by that specification is who owns which tokens. So you have provenance. The asset that it references, the artwork or the collectible, is most of the time not actually stored on-chain, because that would be way too expensive. And the way a smart contract exposes what it points to or what it represents is by a method called the token URI. I'm showing this quite famous art blocks project by Dmitry Cherniak. So anytime you are on OpenSea, you can actually just go to the contract address. So this is the token ID. I'm going to visit the contract on Etherscan. Go to the contract, read the contract. Everybody can do this. This is just open, and this is free for all. And I'm looking for the token URI. And this is important. I hope you can read this. I might get a bit larger. This is the address that the token is pointing to. Let me make a new text file. So this is just a web page. Basically, it's just a JSON file. And if I open it in my browser, you see a whole bunch of properties, the metadata of this token. And this is the one I want to highlight, the media one. And in this case, also the media property also points just to a URL. So in that sense, you could say that this NFT is partially on-chain, the NFT is on-chain, but the assets that it references, the metadata and the image are not. So Artblocks invented another mechanism to still have the code that generates this artwork, to still have it on-chain. And it should be somewhere here. Project script by index. So I took the number 13 from the token ID. And I think this project only has one script. So this is a lot of gibberish that I don't expect anybody to understand this. But the interesting thing is that here, that if this is actually the script that generates the image I just showed. Oh, it's gone. Right? And with this code, anybody could always reconstruct that token in theory. So one of the things, if I, for example, search for the word stroke, which is a method that's being called a few times, this method stroke is actually not defined in this code. The method stroke is part of P5, and that's a library that is stored on another server. So this makes it flexible, because you couldn't store that whole library on chain. That would be too expensive. But then also, by not storing that, you make it fragile again. So there's constant trade-offs in what can you store on chain, how expensive is that, because storing on chain is very expensive in terms of gas, and how flexible are you? Let's see, where was I do something similar with that in my own Mutant Garden Seeder, a project that I made about a year ago. Again, I can go to the contract address, look at the contract, read contract. Actually, I have to remember one. I have to remember the token ID. Here. And again, you see, I get just a web address. And if I open that, I get a JSON file. And in this case, the image points to a vector graphic, which is stored on my server. How I solve the problem of resilience, because if my web server is down, where does the NFT go? Is that people can run a desktop application that does calculates the mutations for you. So this is sort of a sidechain that runs parallel to mainnet, and it calculates the mutations, which is important in my project, because in this project the NFTs actually change all the time based on the current hash, or the current block hash. Let me see. Let me open one. So all the holders of this project can download this software and calculate the mutations on their own without depending on my web server, without depending on anything really. So that aids in the desire for decentralization. I'm going to close this because it costs quite some resources. A project that many of you will know It is actually having another approach is loot. And again, I'm going to just open one of them. We don't have so much time, so I can't really get into the projects themselves individually. So contract, so this is token 442. I'm going to inspect it again. Now, this is interesting. I ask for a URI to a metadata resource file, like a JSON file, but instead I get this gibberish. So it starts with data : application / JSON semicolon base 64 comma, and then I get a whole bunch of gibberish. Now, this is a data URI. So it's not a URI like you're used to, like a URL here with like a domain name, but this is also in most browsers something that's being accepted as a valid URI. So I can copy this whole string and just paste it here. And you should never do this if you get this link from like some hacker or something, because this is also can be risky. But if I open it, you can see that again, it just shows me some JSON file. And JSON is this format to express the properties that an NFT has. So it has a name. Maybe I can make it larger. It has a name, description, blah, 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 until here. And then it has an image. And again, you see this string starts here, data : image. It ends here with a whole bunch of gibberish. If I copy that string, and I have to do it really precise, so include the data part and end before the quote. You see now I have an SVG. So we can also inspect this. See, actually, this is an SVG, a very simple one, because if it would be a very complicated SVG, it would be, again, too complicated to put that on chain. So what happens here? These data URI, it specifies here that it's data, so from there on it knows what to do. It's not HTTP, it's not HTTPS, it's not IPFS. The type of the data that it expects is in this, I think it's a MIME type actually. So it expects, it expects SVG, and that's XML. And the code, this gibberish, is encoded as base 64. And that is a way to express complicated data like images or sound or MP3, or in this case SVG, to express it in characters that will not fuck up data transmission. Because in this gibberish string, you cannot, for example, have a quote, because that would ruin it, or other like non-ASCII characters. And that's basically the trick. So these two steps is, first you encode the entire JSON file in base 64 as a data URI. And then again, in the image attribute, you encode it again. So actually in the end result is that this SVG image has been encoded twice. So you also have to decode it twice. I will go here. So this, there's actually one more way, which is more similar to the first project that I showed on art blocks on my own. Because in those two projects, the art blocks and the Mutant Garden Cedar, the assets referenced were on a web server, on my web server, or in the case of art blocks, on the art blocks web server. There's also one way to store both the metadata and the image, to store that differently on IPFS. So I would say that IPFS is not a blockchain, but it's a distributed file, hosting solution, you could say. So it's already more resilient. If you would take one IPFS node away, the file would still be there. And this particular artwork that I made, you can also on Zora, you can always inspect the contract, and you can inspect the metadata, and it shows, okay, the metadata for this one is stored on IPFS, and the artwork is also on IPFS. So if I click on here, I'll get this here. And I'm inspecting this JSON through a gateway because my browser doesn't by itself understand what IPFS is. If I would do this IPFS, because this is actually how it's stored in the smart contract, my browser doesn't know what it is. I also have Brave. I believe Brave does understand. There's some browsers who can do it. But until that, you have to use a gateway. And this gateway is provided by Pinata. And you can see that the image also references, again, an IPFS hash, which is this one. So if I'm going to refresh it, you can see that takes quite a long time. Because the beauty of IPFS is that it's shared and distributed and safe, but it's also much slower than on a web server. So there's all these trade-offs. I wanted to show that project as well, but we don't have so much time. We only have like 10 more minutes. Yeah, I'm going to show some of the code really quickly of Orb Lite. This is also just available. You can see it on Etherscan. So this token URI method I've been calling a few times, that you have to pass a token ID. This is how I did it. And I can really recommend also, if you like this kind of stuff, to look at the work of Alberto Granzotto. I've actually incorporated and learned a lot from him. I didn't invent any of this. It's I've used a lot. And I can also share these links afterwards in the chat or something. So you can see what is going on behind the scenes when somebody calls token ID, like OpenSea calls it, or Zora, to show what the artwork is. In this case, these animated squircles, this like crooked circles. It returns a string that is based on, and here I'm just doing really crude string concatenation of chunks. I'm just generating JSON here as string manipulation. And this is ugly code because Solidity is really not meant to do this. And you encounter all these limitations and you have to hack everything around, which is also fun. But it feels a bit like early demo scene where people only had 64 kilobytes to make an animation. And then the beauty of the animation was sometimes not so much in the animation, but in the innovation to get so much stuff into so little memory. And I think that's a bit the case with these on-chain Solidity SVG tokens as well. So here is the encoding. Let's see where encode image. The image is here, and it's the SVG method actually does the rendering. It does the base 64 encoding, and the render function is here. So one funny ugly thing, let's see, because in Solidity, for the programmers among us, you can only have like 16 local variables. So if you need more, you have to split up your method into arbitrary sized subroutines. Otherwise, it just doesn't work. So you constantly are confronted with the limitations, but that's also kind of the fun. And the amazing thing is, I think, is that these kind of NFTs are not depending on anything, not a web server, not IPFS. So as long as Ethereum exists, and as long as we have browsers that can display them, this artwork will remain in its animated form, which looks like this. Let's just pick one. And the way that they are being decided on the way they look, the colors they have, the rotation speed, the transparency, is all calculated in the smart contract based on the moment of minting, the seed hash, I think it's called. Let's see if I can show where that is. So there's many uses of this, like random number generators, but actually they are not really random. They are deterministic. So I can be sure that based on the seed or the birth transaction, that they will always show the same thing. And I decided to give all the orbs a temperament or a bias, I call it here. And there's only 4: horny, deep, innocent, and vivid. And these are just returned as strings. For example, here, trait type, temperament, value, get bias string. And these can also be seen here as properties. I can, as example, decode one of them. So again, I go to the contract of this one. Let's say 338 is the token ID. I inspect the smart contract. Then contract, read contract. So these are the methods. I could say render 338. You can see this is just the SVG code as we understand it in just regular code. But to communicate that we need it to be base 64 encoded. So this is just, actually it's a public method, but it's actually never called because the token URI method calls that. So I say, give me the encoded metadata of this token, which is actually quite long, you see. So in here encoded is the SVG code to make those colors and those animation. I'm gonna copy it, paste this here. So again, well, we have still a lot of gibberish, but this has become visible now. So name, description, image, and at the end, the attributes like the colors, the temperament, the amount of rings. And I'm going to copy this again until here. And there we have the SVG. And the SVG is actually, well, relatively complicated if in the sense of like if it can still be encoded. While developing these kind of things, I really recommend before you start getting into the Solidity code, first finish your idea as just as an SVG, just by hand maybe, just in the text editor. Then when you figured out exactly what you want to do, try to program it in JavaScript because JavaScript is much more forgiving. And when you have done that entirely, then port it to Solidity because in Solidity you will encounter many, well, uninspiring problems because it's a very tight, unforgiving language. The tools that I've been using to do that, one is called Hotchain SVG, and I can really recommend it. So for those of you who have ever developed in, for example, React with Webpack and all that, one amazing thing you can do is like when you are coding, the website that you're building refreshes on the fly, so you don't have to refresh or recompile it all the time. And especially for smart contract programming, compiling it and then refreshing it would take a long time. So I've been using Hotchain SVG, so you can type your Solidity code and then each time with each change it reloads. And this is also interesting because sometimes you're coding for a while and then suddenly it just stops because Solidity has all these limitations in the amount of variables you can have or the amount of rendering that you can do at all, because there's still a gas limit. And with this software, you at the most, well, important moment, you just realize, oh, it just stopped working entirely. Because if your smart contract, the rendering of SVG goes over a certain threshold, then it just stops. You don't get an error message, just don't know what happened at all. I will put a link to this also in the notes. That was really short, and I think I've kind of touched everything that I wanted to show. There's one project that I didn't show. I think I should do that because for history, the first project that like I think nobody really argues that that's true. I think everybody agrees that this is the first on-chain generative art piece on the Ethereum blockchain. And so let's inspect how this one stores its data, which is actually quite surprising because like we just said, oh, I have to remember the token ID. Like I just said, the NFTs always have metadata as a JSON file, which points to the asset. Somehow it's forgiven that this one doesn't do that. So instead of outputting metadata, it just outputs the plain immediately the artwork, which is just text. And if I copy this, it is a data URI, but if I just copy this, you can see that this is the artwork, but it doesn't supply other attributes. There's no metadata file, there's no JSON, there's no title, there's no description. It just plainly outputs this. I don't know if OpenSea would accept this for all projects, but this is kind of a seminal artwork, so maybe OpenSea programmed some kind of exception. I don't know, but it's always a pleasure to end with autoglyphs. I think I will give it back to you, Michal. Thank you.
Thank you, Harm. This was, you know, for me, for someone who does not really write any code, it was incredibly insightful, because even I, as an amateur or charlatan, depending on how you define it, I understood so much about how to actually generate such fairly complex works. One question, you know, like, is what's like this skill set that you brought to this? Like, what is your background, maybe also because we have quite a few artists watching, and many of them might not, you know, have a background in coding. So was there something that you did before? You know, are you a developer by trade and then became an artist?
I started programming when I was 11, and
you nerd.
And I studied software engineering, so guilty. Yeah, but I also went to art school, but I must say that like I'm not a hardcore Solidity developer, because I've made some smart contracts and I thought I'm done, this works, and then I had some of my like real Solidity developers like, oh, if you do it like this, you can get hacked or front run or like. So I'm still learning, and I'm approaching it very much from the playful side, but not the I wouldn't program like a DAO or something like that. I would not have the skill set to do that.
Maybe one last question. Somebody who's been, you know, spending so much time with on-chain art, what do you think is, in this regard, the next step, the future? What is it? Something, I mean, we also have quite a few experienced developers that also probably in some groups within the Ethereum community. Is there anything that you wish for the future of on-chain art?
Oh, that's a really good question.
By the way, I don't need to have to understand the answer, you know, so you can really speak to that audience.
Now, one thing, what I would wish in the community is that people have easy resources or easy go-to website where they can inspect how a particular NFT is built and understand how resilient it is and if it can be rugged, and also see if it's innovative in a technical sense. Because I think many people just put all NFTs on one pile, and some of them, I think, like, it's not strange to I think to say that in like 5 years, half of the NFTs we have now will not exist anymore, because nobody's paying for the hosting fees or for the seeding the IPFS hashes, and a lot of money is paid for these things. So education would be good there. I don't know if much will change after the merge of Ethereum, if that will change transaction costs, because if it makes it cheaper, then this kind of stuff might be cheaper to develop. But I'm mostly worried about the provenance or the conservationist aspect of the artwork themselves.
Okay, this was a really interesting answer, and also you just gave a little inspiration for maybe the next hackathon project, because if these tools are missing, then we should find teams to build them for everyone's benefit, because obviously these are tools that should be open source and accessible to all, so we can advance the space together. Harm, thank you so much for taking the time and to lift the veil. So we were able to learn from you, and everyone, please. Harm is actually one of the NFT artists that you can see exhibiting quite a lot around the world. So, and his artworks are really striking in their fidelity once you have them really, really big before your eyes. So please make sure to visit him. Harm, thank you so much.
Thank you.
And have a wonderful day, my friend.
You too. My pleasure. Bye-bye.